Welcome back. I chose to include this section because not only is the first part interesting, but the second part, it has to do with odds. And you might be curious as to what the combination is, excuse the pun, what the difference is between odds and probability. They are related, very closely related, but they're not exactly the same thing. So let's take a look. So section 6, events involving not and or, and also about odds. First of all, we'll look at the probability an event will not occur. Remember, if you think of any kind of event, either it happens or it doesn't happen. So the probability is those two together will total 1. That's key. Also, the probability of one event or a second event occurring, and then use odds. So let's take a look at complement first. One of the things you might do is draw a picture. You can draw a picture of the entire scenario. Make a circle representing your particular event, and since this is the universal set, or set containing anything that can happen, this part over here is not in E, can be written like this with an apostrophe up there. So this is the event happening, this is the event not happening. The probability of all of those together, the universal set, has to be 1. So the probability of E plus the probability of E not happening is 1. That's key to this whole situation. It makes some probabilities easier to calculate, and some that might seem they're almost impossible otherwise. And this makes it simple. So here's one way of looking at it. The probability of E not happening is 1 minus the probability of E does happen. Another way you can look at this is the probability of E happening plus the probability that E doesn't happen, E complement, equals 1. 1.00 if you like, 1 over 1, whatever. So for an event, you can also create an event and say it's 1 minus the probability it won't happen. Just the opposite. So these two are really the same thing, but just with a focus on E not happening versus E happening. If you remember this one right here, this covers both of those situations. So here's E is the event, E is the complement of the event, or E not happening. Those are your two formulas. You could keep both those, or you could just keep this one up here. That's up to you. Whichever way happens to make sense to you. So let's take an example. We're going to pick one card from a standard 52 card deck. We want the probability that you're not dealt a queen. So the probability of a queen is your event. And what you want is the probability that you didn't get a queen, the complement of that event. So how do we get it? First of all, get the probability of getting a queen. Well, the probability of getting a queen is 1 over 13. If you missed something, that's because there are 52 cards in your deck. That goes in the bottom. Total 52 cards. And there are 4 queens in the deck. Reduce that and you get 1 over 13. That's the probability of getting a queen. To get the probability it's not a queen, you just subtract that from 1, as is shown right here. So your probability is 12 over 13. And you can change that to a decimal if you like. Mutually exclusive events. Sounds exotic? It really isn't. Mutually exclusive just means there are 2 things that you're thinking about, 2 events, and they can't happen at the same time. Does that make sense? Well, maybe not until you get an example. Another way of saying it is they can't occur simultaneously. Impossible. If they're mutually exclusive, for example, like the getting a queen versus not getting a queen, they can't both happen at the same time. If they're mutually exclusive, but if they can't happen at the same time, then the probability of A or B, or is the key here, is the sum of the 2 individual probabilities. In set notation, A union B is the same thing as A or B. And if they're mutually exclusive events, that means they won't happen at the same time. There's no overlap like this. Nope. No overlap, then just add the individual probabilities because the sets look like this, having nothing in common. So let's look at another one. You're choosing 1 card from that 52 card deck. What's the probability of a king or a queen? Key here is or. And the other key is, can they happen at the same time? If you pick 1 card, can it be a queen and a king? No. That might seem obvious to you, I hope. So they're mutually exclusive events. So all you need to do is get the probability of getting a king, add it to the probability of getting a queen, and you got your result. The king, there's your probability because there are 4 kings in a deck. The probability of 4 queens, or of 1 being a queen, 4 queens, 52 cards. Just add those 2 together since they can't happen at the same time. And from here to here, all you're doing is reducing that fraction. If they're not mutually exclusive, things get a tiny bit more complicated. If they can happen at the same time, then we have to add an additional subtraction out here. Because when you add the probability of A and the probability of B, you're adding the probability of A and B happening at the same time twice. Once over here, once over here. So you have to subtract it out to get only one of those intersections or one of those simultaneous events. In set notation, here's your OR statement. There's the probability of the first event, the probability of the second event, and there's the probability that they both happen at the same time. Now, let's take a look at the zoo, I guess. You've got 25 baboons, 18 like grooming, 16 like screeching wildly, and 10 enjoy doing both. If 1 baboon is selected, find the probability it enjoys grooming, or, there's the key, or. And also, can they do both at the same time? Can they enjoy grooming and screech wildly? Well, yes. So, if we want the solution, since 10 enjoy both of them, here's the probability they like grooming, the probability they like screeching, and in that process of adding those two together, we had these 10 twice. The 10 were included in the 18, the 10 were included in the 16 as well. So a little bit of arithmetic there, simple fractions, and there's our probability. This is the probability that one of the baboons selected at random either likes being groomed or likes to screech wildly. 24 over 25. Not much of a chance of missing. Now, get to the probability of odds. Probabilities and odds, as I said, are very closely related to each other. Not in a complicated way, but maybe in a little bit of a tricky way. So you have to give this some thought and work with it a few times, as in maybe 10 times, 15 times, until it finally clicks. The odds in favor, now there's going to be two. In favor, against. Two different kinds of odds. This one will be the probability of E occurring divided by the probability that E will not occur. Odds. Will to will not. And the other way of writing this would be you could make this into a fraction. Oops. Make this into a fraction, something like that. And let me clear that. It's getting a little messy. There we go. This is the odds in favor of E. So the E goes on top and the not E goes on the bottom if it's in favor. Now if you want it the other way, if you want the odds against E happening, you just swap the numerator and the denominator. Put not E on the top for against, not E on the top, E on the bottom. And there's the odds against. In favor, E goes on the top, against, not E goes on the top. All you need to do to go from one to the other is just reverse the ratio. Turn it upside down or left to right, whichever way you happen to be describing your odds. So, to go from probability to odds, let's suppose you roll a 6-sided die, a typical one. You want the odds in favor of rolling a 1. So what's the a 2. What's the probability of getting that 2? There's only 1 2 on the die, so 1 on the top. There's 6 possible results. There's the probability of getting a 2. And then you also want the probability of not getting a 2. Well, there are 5 ways you can get something other than the 2. So 5 goes on the top, and there's 6 sides to the die. Those are the 2 pieces you need. So here's our sample space. Here's the probability of getting that 2. There's the probability of not getting the 2, 5, 6. Put those together. Since it's the probability of in favor, you put the probability of E on the top and not E on the bottom. So it'll be 1/6 over 5/6. Invert the divisor. This is the divisor, the second one, the one you're dividing by, and then multiply. The 6's cancel. Your odds are 1/5 or 1/5. Odds to probability. If we go the other direction, the odds in favor are A to B. Then the probability of the event is given by A over A plus B. Why is that? Well, this is the probability that E happens, this that it doesn't happen. So adding the two together in the denominator gives you the probability of any of those two happening. So let's look at a horse. Okay, we're going to the racetrack, and the odds in favor, remember this is in favor, so it's E to E prime, is 2/5. What's the probability the horse will win the race? Well, the probability of 2 needs to go on the top. And on the bottom, you have 2 and 5. Let's clean this up before it gets too messy. There we go. So the odds in favor means the probability of A over A plus B. Excuse me. So 2/5 means 2 goes on the top because you're in favor, and the total goes on the bottom, 7. There's your fraction, and the probability the horse will win the race is 2/7. If you throw that in your calculator, you can see that's about 28.5%. So somewhere a little bit over 1/4 of a chance. All right, so odds and complements, odds in favor, odds against. You should be able to work a few of these problems. I hope you understand the connection between odds and probability. Okay, until next time, take care.